Hello students, today we are going to study about the chapter structure of atom. In previous chapters you are study about the definition and more about the atoms and molecules. Now here we are going to study about atom, structure of atom. Students, John Dalton was the first chemist who first in 1804 first proposed a model of an atom. He described about how an atom is appearing and what kind of the matter is, what kind of the atom is made up of. From the earlier definitions, you also know about what is an atom. An atom is the smallest particle of any substance that has ability to take part in chemical reaction. Now here students, we are going to know about the Dalton's atomic theory. Dalton's atomic theory. John Dalton first proposed the theory of an atom. This theory is known as Dalton's atomic theory. What the concept or postulates he gave in theory? Now look at here. He stated that an atom is the smallest indestructible particle of any substance Next, an atom can't be created and can't be destroyed. An atom cannot be created and cannot be destroyed. Next concept he gave about the atom was all the atoms of any element are alike in all respect. It means all kinds of behaviors in all respect. It means they are just identical in all respect. Next, the atoms of different elements are different nature and behavior. nature and behavior. Next, he told that the atom can be exist freely in nature, but after the passage of time, the Dalton's concept on the atom was proved to be discarded with with its demerits. Taken an example, Dalton stated that an atom is the smallest indestructible particle of any substance. It means that an atom cannot be break down into their fundamental particles. But after the discovery of three fundamental particles of an atom, electron, proton, and neutron, the modern concept of the atom, or you can say that the modern concept for this sentence of the Dalton's atomic model has been changed. Then, how can we modify the Dalton's atomic model? On this behalf, we can modify the Dalton's atomic model that an atom is the smallest particle of any substance that is consists of three fundamental particles. It means electron, proton, and neutron. Now, the second concept was given by Dalton is that an atom cannot be created and cannot be destroyed. But students, there are certain radioactive elements, and the process of radioactivity and nuclear reactions are helpful in the creation and destroy a heavy nuclei into the lighter nuclei to obtain the new elements from any heavy elements. We know about these reactions, these nuclear reactions ahead, but from this point of view, the modern concept of the Dalton's atomic theory can be changed as an atom can be created and can be destroyed with the help of nuclear fission and nuclear fusion reactions. We know about the nuclear fission and nuclear fusion reactions ahead. Next, Dalton stated that all the atoms of any element, any certain elements, it means any particular elements, are alike in all respects. But after the discovery of isotopes, this phenomena or concept of the Dalton have been changed. How? Taking the example of three isotopes of hydrogen. This is the 1H1 protium, 1H2 deuterium, and 1H3 tritium. Protium, deuterium, and this is 1H3 tritium. What we find here, this represents the atomic number. It means the position of the elements, but this represents the number of proton and neutron present in the atom. What we find here, these are the three isotopes of hydrogen, 1s1, 1s2 and 1s3. What are isotopes? You also know about isotopes. Isotopes are the kinds of atoms of certain elements having the same atomic number. It means here we look at the atomic number of all three hydrogen atoms are same. It means 1. But their mass number are different. So that you can define the isotopes. Isotopes are the kinds of atoms of elements having the same atomic number but different mass number, that are called isotopes. With the discovery of isotopes of certain elements, the concept of the Dalton's atomic theory that all the atoms of any elements are alike in all respects have been discarded with the discovery of isotope. Then how the modern concept about this sentence can be given? The modern concept on this behalf can be given: all the atoms of any elements may not be alike in all respects. It means they have variation with the increasing or decreasing the number of proton and neutrons in their nucleus. Now students, the another concept given by Dalton is that the atoms of the different elements are different in nature and behavior, but with the discovery of isobars, if we taking the example of argon, atomic number 18, mass number 40, and calcium, taking the symbol Ca, atomic number 20, and the atomic mass or mass number is 40. What we found here, this is the argon, a noble gas whose atomic number is 18 and the mass number is 40, and here also this is a alkali element whose atomic number is 20 and mass number is also 40. There is two similarities between both atoms of element. What is the similarity? Their atomic mass or atomic number is same, but their mass number or atomic mass is same, but atomic number is different. That are called isobars. Isobars are the kinds of atoms of different elements having same mass number but different atomic number. Iso means alike and bars means weight or mass. That's why they have different mass number. Hence called isobars. Thus, the concept of the Dalton's atomic theory was also discarded due to the discovery of isobars. The atoms of the different elements are different in nature and behavior, but here it is exemplified that the atoms of the different elements may not be different in nature and behavior. The last concept was given by Dalton: the atom cannot be exist. The atom can be exist freely in nature. But students, after the discovery of fundamental particles, electron, proton and neutron, and it is clear that an atom cannot be exist freely in nature. It always found in ionic state or its molecular state. As you know that water molecules, two or more than two atoms unite to form a molecule of particular elements. Thus students, now we are discussing about the modern view of Dalton's atomic model. Or you can say that the present position of Dalton's atomic model. Present position of Dalton's atomic model. First of all, I take the modern concept of the Dalton's atomic model. An atom is the smallest destructible. It means it can be break down into more smaller particles. Destructible particle of any substance, because an atom is consist of three fundamental particles. Electron, proton, and neutron. Second is that an atom can be created and can be destroyed. An atom can be created and can be destroyed. How? Take an example of nuclear reaction. First, I take the example of nuclear fusion reaction. Students, in nuclear fusion reaction, the two lighter nuclei combine to form a heavy nuclei. 1s2 plus 1s2. These are the deuterium of, or you can say that isotope of hydrogen, deuterium and deuterium. It combined to form 2Hg4. It means a heavy nuclei of helium plus tremendous form of energy is liberated during this process. Tremendous form of energy is evolved during this process. Students, the sun's energy of nuclear fusion reaction. As you know that sun is a hot ball of fire. Its nucleus is made up of helium. This helium gas provides the lots of energy to the sunlight or other stars like to the sun with the reaction of nuclear fusion reaction. The term fusion means collapsing. It means joining or linking. Thus, students, we know more about the present position and model concept of Dalton's atomic model in next video lecture. Thanks, students, for coming today.